In this video, we're going over the exponential equation. So solving for x, and notice how x is in the exponent. Now here we could just do mental math, right? Like 2 to the what power is going to equal 16? Well, I could say 2 to the fourth power, right? 2 to the fourth power is equal to 16. So that's kind of like a mental math thing. Now, mathematically, let's say you can't do the mental math, right? A way to go about doing this is, well, again, if when we had exponentials, we could write it as a log. So here I've got log base 2, right? Because this is my base. So this is log base 2 of what? So base 2 of 16, right? Remember, it's like a big circle. So log base 2 of 16 is equal to our exponent, which is x. So now notice we have here our change of base. So I could set up and divide my two log values, right? Because this is log 16 divided by the base here, log 2. And you should, if you put that in the calculator, you do get x is equal to 4. So then here, now, just like when talking about other equations in the past, with our exponential, we've got to get it by itself. See how we're subtracting 32 outside of it? So we need to first add 32 to both sides of the equation. So I've got 2 to the x is equal to 32. So again, 2 to the what power is equal to 32? Well, 2 to the fifth power. So let's check that, right? So let's write it as a log. So again, this is log base 2 of 32 is equal to our exponent x. So now notice here again, right? Change of base. So I've got log 32, right? Divided by log 2. And you do get 5. So now here I've got our exponential 9 to the x plus 4, but it's being multiplied by 3. So again, just like how we were subtracting 32, so we added 32 to get the exponential by itself. We're multiplying by 3, so we need to divide both sides of the equation by 3. So now I've got 9 to the x plus 4 is equal to 9. Now, we're about to get to a property, but you'll see here how the bases are technically the same. So I'm just kind of giving you a precursor here. So the bases cancel out and you set the equation equal to the exponent. So like this is x plus 4 is equal to 1. So just a little precursor about what we're about to get to. You can see how both bases are 9. So I could set up and solve. So here, let's see if we get the same answer, right? So again, now that the exponent is by itself, write it as a log. So this is log base 9 of what? 9, which is equal to not just x, right? My exponent is now x plus 4. So again, practicing your change of base here, right? Because this is log 9 divided by log 9, which is just 1. Notice how we had 1 here, right? Is equal to x plus 4. So now here we still need to solve for x. If I'm adding 4, subtract 4. So x is equal to -3. So again, you got to get the exponential here by itself. Now notice we have e here, which is still our exponential, but it's being multiplied by 7. So what do we have to do first? Divide by 7. Opposite, right? So now e to the 2x plus 5 is equal to 4. Now, here we can't really rewrite this as a log because it's a base e. But what is the inverse of e? ln, right? So what we do to one side, though, we're going to do to the other. So we're going to take the natural log of both sides of the equation, because now here they cancel out and bring down 2x plus 5, which is equal to not just 4, the natural log of 4. So practice putting that in the calculator and you get about 1.4 approximately. So now notice we are solving a two-step to solving for solving for x here. So what do we need to do first? Subtract the 5, right? So now I've got 2x is equal to negative 3.6. Then divide by 2, and you get x is equal to negative 1.8. So again, the focus is get the exponential by itself before you start solving and writing it as a log and solving for x here. So go ahead and pause the video and try the 4 U tries on your own. And here we go. So notice how here for the first U try, the exponential is by itself. There's nothing outside of it. So write it as a log. So here we go. We've got log base 4 of 5 is equal to x minus 1. So now notice here's your change of base, right? So you should have set this up log of 5 divided by log 4, which is equal to approximately 1.16, which is equal to, though, x minus 1, right? So now here to solve for x, add 1. So x is approximately 2.16. So then here, now the exponential was not by itself, being multiplied by 2. So you need to divide by 2 first. So e to the 3x minus 2 is now equal to 13. So now here, when we had e, well, what's the inverse of e? ln, the natural log here. So canceling out, bring down the exponent, 3x minus 2. But that is not equal to just 13, right? The natural log of 13, which is about 2.56. So now here, solving for x, right? We're going to add 2. So now you've got 3x is equal to 4.56 and divide by 3. So you get approximately 1.52. So then the next one, the exponential was not by itself. So you needed to first divide by 8. So now here you've got 2 to the x plus 1 is equal to now 4. So now see how the exponential is by itself? Write it as a log. So now log base 2 of 4 is equal to x plus 1. So now here, change of base, you end up with 2 is equal to x plus 1. Subtract 1 and x is equal to 1. So then our last one here, now the exponential again, not by itself, you're adding 6. So you need to first subtract 6, right? Get the exponential by itself. So now you've got 3 to the 2x is equal to 21. So again, it's an exponential. Don't divide by 3 and say 7, right? It's an exponent. Write it as a log. So this is log base what? 3 of 21 is equal to 2x. So now here you end up with approximately 2.77 equal to 2x. Then divide by 2, you get x is approximately 1.38 or 1.39, however you want to round that here. So that is your approximation. So now here, notice how you have exponents on both sides of the equation. So this is using that property of the bases. If the bases are the same, then they cancel each other out. So notice how they're both a base e. So guess what happened? They cancel each other out. And you are left with bringing down 4x plus 1 is equal to 2x plus 7. Now you're just solving for x like it's a multi-step. So I'm going to gather my variable and subtract 2x. Now, can you subtract 4? Of course. I just like subtracting the smaller amount because you're going to end up with a positive. So now I've got 2x plus 1 is equal to 7. Now you're just solving your two-step here. Subtract 1, you've got 2x is equal to 6. Divide by 2, and x is equal to 3. So again, if you've got the two bases that are the same, they cancel out. But now notice these bases are different, right? I've got a base 3 and a base 9. So the key is this. We're going to bring down the smaller of the two bases to rewrite 9 here. So this is 3 to the x plus 8. Because now I need to rewrite 9 so that it's a base of 3. Because we want the bases to be the same. So 3 to the what power is going to give you 9? Well, 3 to the second power, right? But then remember, you had your exponent here. So we're going to bring that down. 5x minus 5. So this is rewritten as 3 to the second power, then times that 5x minus 5. So now notice the bases now are the same. So I can bring down x plus 8 is equal to, now notice, this is not just the 5x minus 5, right? But 2 times 5x minus 5. So now notice we need to distribute first here. So 2 times 5x, which is 10x, and 2 times negative 5, which is negative 10. Now we can start solving our multi-step. So I'm going to go ahead and subtract x from both sides. And I've got 8 is equal to 9x minus 10. Now we're just solving our two-step. Add 10 here to both sides. You've got 18 is equal to 9x. Divide by 9, you get x is equal to 2. So notice here, if the bases are the same, they cancel out. So if they're not, convert so that they are the same. So go ahead and pause the video and try the 2 U tries on your own. And here we go. So the bases are different, right? So I'm going to bring down 4 to the x minus 2, right? Because if this is a base 4, then 16 needs to be written as a base of what? 4. So 4 to the what power gives you 16? Well, 4 to the second power. Then bring down the original x plus 5. So now notice the bases are the same. So here I can distribute, and I've got 2x plus 10 to bring down is equal to x minus 2. Now we're just solving our multi-step equation. I'm going to gather my x's. Now I've got 1x, or x plus 10, is equal to negative 2 here, right? Watch your signs. So now here, when you subtract 10, you end up with x is equal to negative 12. Now here, the bases are the same. So what happened? They just cancel out. Bring down 3x minus 4 is equal to 5x minus 8. Now gathering, I'm going to subtract 3x here from both sides. Now I've got negative 4, right? Keep the sign in front, is equal to 2x minus 8. Now we're solving our two-step. So here I'm going to add 8 to both sides. And now I've got positive 4 here is equal to 2x. Divide by 2, and you get x is equal to 2. So now here, getting into our application. So like, for example, we are starting at 10 volunteers, and then the amount of volunteers doubles. So here, when we want to show this situation, the doubling, that's 2 to the t power, and then you're starting, right, at 10. So this is the function that represents the situation, where again, V is the number of volunteers and T is your time in weeks. But now notice the question is, how many weeks is it going to take for the volunteers to reach 15,000? So what does the 15,000 represent, V or T? V now, because that's your total volunteers. So if we were to use this function, we would set this up as 15,000 is equal to 10 times 2 to the t power. Now, to graph this, and just to show you, if you were to graph this in Desmos, this is the same as typing in, so here, y is equal to 15,000. That is your line in red. So whenever it's just 15,000 or a number, you have to put y equals. Then the blue here is just 10 times 2 to the t, or if you're putting this in Desmos, 10 times 2 to the x power. And you will see this graph. Then just like before, wherever they cross is your solution. So notice how here, where they're crossing, is about halfway between 10 and 11. So we're approximating 10.5. So now let's go through and solve, right? So here we have to get the exponential by itself, but it's being multiplied by 10. So what do we have to do? Divide by 10 now. So this is 1500 is equal to 2 to the t. Now that the exponent's by itself, what do? Write it as a log. So this is log base what? 2. Log base 2 of 1500 is equal to t. So now all we have to do is just change of base. Log 1500 divided by log 2. Now when you put that in the calculator, you get approximately 10.55. So it matches our estimate here when we were looking at that. So again, notice if you wanted to graph, this is the setup in Desmos for graphing. And it's where they cross. So like here, go ahead and pause the video. So here we're using the same function. So the v of t is equal to 10 times 2 to the t power. So now let's see how you would set it up if you had 1,280. And here we go. So again, this represents the number of volunteers. So this is 1,280 is equal to 10 times 2 to the t power. So now for those who wanted to graph in Desmos, you would graph y is equal to 1,280. Then on the second line, you just graph 10 times 2 to the x. See where the two graphs cross each other? And we're going to solve this to see if we get the same answer. So again, here, what do we have to do first? Divide by 10, right? Because it's being multiplied. So I've got 2 to the t is now equal to 128. So now don't divide by 2, right? It's an exponential. Write it as a log. So log base what? 2 of 128 is equal to the exponent t. So now setting this up as your change of base, right? Log of 128 divided by log 2, you actually get a whole number of 7. So when you graph this in Desmos, they should cross at 7. So here, pause the video, read through. Notice how we're talking about this value of 10,000. So let's see what you think this 10,000 represents and how you set up using this function here. So let's see here. 10,000 represents the number of members. It's asking for how many months. So that is your time, M for months. So you should have set this up for your party. That's your P. So here we've got 10,000 is equal to 500 times 2 to the M. So again, if you wanted to practice in Desmos, you would type in one line, y is equal to 10,000. And then in the other, you would put 500 times 2 to the x, and then see where they cross each other. So now here, we're going to go through and solve this algebraically. So if you're multiplying by 500, divide by 500. So now I've got 2 to the m is equal to 20. Now don't divide by 2 and say my answer is 10, right? So now here we need to convert this as a log. So this again is log base what? 2 of 20 is equal to m. So now change of base, right? Log of 20 divided by log of 2. And here you get approximately 4.3 months. So now the next one. You're compounding continuously using this function here. So starting value at 850. But how many years? So how many years, RT, will it take for the account to reach the 1500? So that is the final amount. So 1500 is equal to 850 times e to the 0.05 times t power. So now notice we're solving for t. Again, you can graph in Desmos to see where they cross, right? Y is equal to 1500. And your other line here, just make sure to put X instead of T. Here, we'll go through and solve algebraically. Now notice our exponential is being multiplied by 850. So what do we have to do first? Divide by 850. So now here I've got, when you divide, you get about 1.76 is equal to, e to the 0.05 t power. Now, we have an e. So what does that mean? Well, what is the inverse of e? Natural log, ln. So now here, right, this is not just 1.76, it's the natural log of that. So approximately 0.56, I'll round that up to 8, is equal to, bring down 0.05 t. Now divide by 0.05, because that's what's being multiplied to our t value. And you get approximately 11.4 years. So go ahead now, pause the video, and try this one on your own. And here we go. So notice how you're solving for how many years. So you're solving for t, the population, 25,000. So 25,000 is equal to 14,000, the starting times 1.04 to the t. Notice how this is a growth function, right? Because it's greater than 1. So now here, you're multiplying by 14,000, so divide by 14,000. And so now here you get approximately 1.786. That is equal to 1.04 to the t power. So now notice you write this as a log. So here you've got log base 1.04 of 1.786 is equal to t. So now putting that in the calculator, right, because that's your change of base where you divide the two logs, you get approximately 14.78 or 14.8 years, or even approximately 15 years. So all that's left now are practice problems. So go ahead and pause the video, and then I will just quickly go over these to make sure that you got the correct answer for these practice problems. Okay, so for the first practice problem, don't divide by 2 and say 5, right? Because it's an exponential and it's by itself. So you can just write it as a log. So here you've got log base 2 of 10 is equal to x. And here's your change of base. Log 10 divided by log 2, you get approximately 3.3. So then here again, exponential is by itself, write it as a log. So this is log base 7 of 21 is equal to x plus 5. So now here again, change of base. Now putting this in, you get about 1.56 is equal to x plus 5. Subtract 5, you get negative 3.44. So then here, this is practicing converting so that they have the same base. So I'm going to bring down 5 to the x plus 3, but write 25 as a base 5. So 5 to the second power, then 4x minus 14. So now bases are the same, cancel out, distribute. So you've got 8x minus 28 is equal to x plus 3. So now when you gather, subtract x from both sides, 7x minus 28 is equal to 3. So now you add 28, you've got 7x is equal to 31. Divide by 7, you can leave it as a fraction or get your decimal, but 31 over 7. So then here for the next question, again, exponential is by itself, write it as a log. So this is log base 2 of 15 is equal to 3x. So now here, you have your change of base, you get about 3.91 is equal to 3x. So now this is the approximation, but when you divide by 3 from this change of base here, you get approximately 1.3. Then here, your e exponential is by itself, but don't write it as a log, right? Because the inverse of e is natural log, ln. So here you solve x minus 12 equal to the natural log of 5, which is about 1.61. So now here, when you add 12, you get x is approximately 13.61. So now here, to solving this exponential, it was not by itself. You had to subtract 1 first. So this is 6 to the 2x minus 1, is equal to 36. So a couple of ways that you could solve this, but I'll go through the change of base. So this is log base 6 of 36 is equal to 2x minus 1. So now when you do change of base, you get 2x minus 1. So now you solve the two-step, add 1 to both sides. You get 3 is equal to 2x and divide by 2, which is why the answer here is C. Then now here you're looking for which has a solution of -4. So option 1, you go through and solve, or you could graph using Desmos. So you graph the left side here, 5 times 2 to the x. Now, because this is a number, right, you have to put y is equal to the fraction 5 over 16. Same thing here. You put in the left side, and then the right side, you put y is equal to 48 on the next line here. But here in the end, where they look to see where they cross, which cross is at -4, the answer is A. And the last one here, you're looking to see which of these represents the equation solving for t. Notice how t is in the exponent, but you got to first divide by 7. So divide by 7, right? So y over 7 is equal to 2 to the t over 30 power. Now the exponential is by itself, write it as a log. So this is log base 2 of y over 7. That is equal to your exponent of t over 30. So now notice you are dividing t by 30. So now what's the last step? Multiply by 30. That's why the answer here is A.